coming back to our steps of hypothesis testing, we're going to work toward these test statistics. So now we're working toward the calculations. We're going to calculate the test statistic, and we're going to use a table of constants to figure out where our rejection region is, and that's going to be dependent on the significance level. In this case, our alpha is 0.05 for the pumpkin fillings. And again, what we're concerned about is type 1 error. So written down, the type 1 error is saying we're going to reject the null hypothesis when we actually should have accepted it. Whereas the type 2 error, we're accepting the null hypothesis when we should have rejected it. So one is putting someone in prison by accident. The other one is letting them loose by accident. So if you said this person is, the null hypothesis is this person is innocent, the type 1 error would be to let them go when they actually, to convict them when they were actually guilty. So, okay. And here's a nice table that really illustrates that concept. So if the null hypothesis is true, that this person truly is not guilty, and we accept that null hypothesis, then that's the right decision to make. If the alternative hypothesis is that this person is truly guilty, and we're going to say that the alternative hypothesis, and we actually do that, we're going to do the right decision, right? But you can see the table. If we say that the null hypothesis is false, then we make the wrong decision because that person was innocent. Does that make sense? It's one of those tables. I always have a hard time explaining it, but I can see it when I look at it in person. But I think you get the idea. But it comes back to that example of if you're doing microbiological testing, or in this case with the pumpkin pie filling, you might accidentally make a decision to reject or accept a lot that's actually wrong. So before we get too far into it, just a couple other things to jog your memory or introduce terms to you. Have you heard the term power? It's the probability of correctly rejecting the null hypothesis. We're not necessarily going to use that. These are terms I just kind of put out there just in case it helps you. The confidence interval is the estimated range of values likely to include an unknown population parameter. And that's where you'll see the 95% confidence interval is associated with the alpha of 0.05. And then we have this p-value, which is the probability that the test statistic will have a value at least as extreme as the observation value of the statistic when null hypothesis is